In section 5.6, we want to learn how to solve rational equations. So again, to review, we've graphed rational functions, we've dealt with inverse and joint variation, we've added, subtracted, multiplied, and divide with rational expressions. Now we're going to work with solving equations. So to key vocabulary, some stuff you should be familiar with: cross-multiplying. The idea of cross-multiplying is when you have a fraction is equal to a fraction, you cross-multiply. What this basically is multiplying by the least common denominator, right? The least common denominator is b times d. When I multiply this times b times d, the b's cancel and I get d times a. And when I multiply this side times b times d, the d's cancel and I get c times b. So a times d, b times c. That's what I end up with. So cross-multiplying and multiplying both sides of the equation by the least common denominator, both are methods. They're the same method actually, and they get rid of all the fractions. So that's very helpful in solving, and especially helpful if you're not really fond of fractions. So anytime you have an equation that has fractions in it, if you multiply both sides of the equation by the least common denominator, all the fractions will be eliminated. And again, extraneous solution we've already learned about. These are solutions that you can solve algebraically, but they don't actually work in the initial equation, so they're false solutions. All right, a problem that I might want to work with, this is a rational equation, right? It's an equation because I have an equal sign. This is a rational function. And in this case, I've got a formula for the annual sales of entertainment software in billions of dollars for a period of 8 years, from 95 to 2003. What's important when you're given a range like this, you have to understand that 1995 would be year 0, 2003 would be year 8. So when we're talking about here, 0 is 1995, and 8 is 2003. So when you're looking at the years in between, when you get t is equal to 2, for instance, that would be 1997. Okay, so at the end of the lecture, we'll go ahead and we'll solve this, figure out for which year were total sales of entertainment software about 5.3 billion. There are several different ways we can do this, and we'll talk about that when we get there. Solve a rational equation by cross-multiplying. Check for extraneous solutions. So cross-multiplying is typically what we do when we have a fraction equals a fraction. So I'll have x times x is x squared. And I'll have negative 1 times x squared minus 2. So I'll have negative 1 times x squared minus 2. Right? When I go ahead and simplify this out, I'll have x squared is equal to the opposite of x squared plus 2. When I add x squared to either side, I'll get 2x squared is equal to 2. That means that x squared would be equal to 1, so x is equal to plus or minus 1. If I want to check for extraneous solutions, I would plug them back into the original equation. So I'd have 1 over 1 minus 2 is equal to negative 1 over 1. So 1 minus 2 is negative 1. 1 divided by negative 1 is negative 1. Negative 1 by negative 1 is 1. That checks out. If I plug negative 1 in, I'll have negative 1 over negative 1 squared is 1 minus 2. Negative 1 over negative 1. Negative 1 divided by negative 1 is 1. Negative 1 by negative 1 is 1. Yeah, that checks out. So both of these are solutions. If I move on to my next problem, I'm going to cross-multiply. Now, when you have a lot of factors, I discourage you from immediately combining everything. Right? You don't want to immediately combine everything, because when I have, for instance, 4 on either side of the equation, I can divide both sides by 4 and get rid of it. Right? Factors of 8 that have a difference of 2, 4 and 2, so this is going to be x plus 4 times x minus 2. One of the things this helps you do is if you cancel common factors that are on either side of the equation by dividing both sides, it'll cut down the number of extraneous solutions you find. So I have x minus 4 is equal to x minus 2. So when I try to continue through, first off, when you look at this, this should strike you as strange. How could x minus 4 be equal to x minus 2? How is that possible? When I subtract x from either side, I'll get 0. When I add 4 to either side, I'll get 2. 0 is equal to 2. That is never true. That is not possible. This is a circumstance where there is no solution. So when you solve through one of these problems and you get to an untrue statement, 0 is equal to 2. That means there's no solution. If, on the other hand, I got a true statement like 2 is equal to 2, that means that there are an infinite number of solutions. Okay, so that's important to keep in the back of your head when you're thinking about solutions. So this can happen where you come out with something that's just not possible. This is how you interpret it, no solution. So go ahead and try solving by cross multiplying. Do problems 7, 8, and 9, and then come on back. Okay, so writing and using a rational model. So let's look at our information here. An alloy is formed by mixing 2 or more metals. Sterling silver is an alloy that is composed of 92.5% silver and 7.5% copper by weight. Silver jewelry, regular silver jewelry, not sterling silver, is 80% silver and 20% copper. So sterling has less copper. How much pure silver should I mix with 15 ounces of silver jewelry to make sterling? So what we're talking about, if they've given us the percentage of copper in a mixture, so what I can figure out here is I could figure out the amount of copper, but really what we're talking about is the silver. Okay, because it's how much silver are we going to mix. So this is nice to know. I could figure out how much copper I had, which would be helpful. So I know that I had regular silver, so it was 20%, right? So how much of this, 20%, I have 0.2, is equal to, I don't know how much copper out of 15. When I multiply both sides by 15, I'll get 3 is equal to x, but that's x in this case would be the copper. But we're really concerned about the silver. So if I have 3 ounces of copper in my 15 ounces of jewelry silver, that means that 12 ounces of it is silver. So now if we look at the percentage of silver, because that's what really matters, right? If I look at the percentage of silver, it needs to end up being 92.5%. So that's 0.925. And it's going to equal the amount of silver I have, which is 12, because 15 minus 3 is 12, and the amount I had plus an unknown amount of silver that we're going to add to either side. So the 12 ounces of silver plus an unknown amount of pure silver divided by the 15 ounces of total jewelry silver plus an unknown amount of pure silver will make a certain amount of sterling silver. So I multiply both sides by the denominator. I'll get 0.925 times 15 plus x will be equal to 12 plus x. And when I do 0.925 times 15, it becomes 13.875 plus 0.925x will be equal to 12 plus x. When I subtract 0.925x from either side, I get 0.075x. And when I subtract 12, I get 1.875. 1.875 divided by 0.075 will equal 25. So how much silver do I need to add? I need to add 25 ounces of silver. Okay, so that's setting up the ratio. I could have set this up as copper, I suppose, in a way, but it would have been much more difficult. And I set it up to be silver because they asked me how much silver. If I'd wanted to set it up by copper, it would have been how much copper do I remove? that really would be much more difficult to look at and not really the question they asked. Okay, so I used this to figure out how much copper was in, because by knowing how much copper there was, that told me how much silver there was. All right, another example for the types of rational expressions we might, or rational equations we might have, involves, now you see I have a subtraction problem here. I have an addition problem here. It's not, I can't just cross multiply. However, as I mentioned to you, cross multiplying is just multiplying both sides of the equation by the least common denominator. This has a denominator of 1. That's unimportant. I have x and I have x plus 3. So the least common denominator would be x and times x plus 3. Knowing it is not used so that I can create common denominators, but so that I can multiply both sides of the equation by the common denominator and get rid of all the fractions. When I multiply x times x plus 3 times 5 over x, the x's cancel, and I get 5 times x plus 3. Minus, when I multiply this whole thing times 2, it's just going to be 2 times that. 2 times x plus 3. Or I could get rid of that one parentheses and just make it 2x times x plus 3. And that will equal, when I multiply x times x plus 3 times this, the x plus 3's will cancel, and it'll just become 2x. When I simplify this all out, I'll get 5x plus 15 minus 2x times x is 2x squared plus 6x is equal to 2x. When I go ahead and take the parentheses off, I'll have 5x plus 15 minus 2x squared minus 6x equals 2x. And now I'm going to want to put everything, this is a quadratic function. I want to make it equal 0, so I'm going to take everything and I'm going to put it on the far side of the equation, because I don't want minus 2x squared. I want positive 2x squared, and by adding it to either side of the equation, that's what I'll get. So I know that this side's going to end up equaling 0. I'm going to add 2x squared to the other side. That's 2x squared. 5x minus 6x is negative x. So I add x to either side. That's going to become 3x, and I subtract 15. Now what I'll want to do is I'm going to want to factor this. So I have the products of 2, or the factors of 2 and the factors of 15 that are going to have a difference of 3. So 15 is 3 and 5. It's also 1 and 15. And this is 2 and 1. So I want a difference of 3. So 10 and 3. Now that has a difference of 1. Or sorry, 10 and 3 has a difference of 7. My mistake. 6 and 5. That has a difference of 1. 2 and 15 is a difference of 13. So this is non-factorable. So I would want to go ahead then, and I would want to probably use the quadratic equation to solve this problem. So let's go ahead and do that. So I'm going to have x would be equal to the opposite of 3, so negative 3, plus and minus the square root of 3 squared, which is 9, minus 4 times 2 times negative 15. All over 2 times 2. So this will be negative 3 plus or minus. Now this becomes 120. So it's going to be the square root of 9 minus negative 120 is 129 over 4. Okay, so these would be my two solutions. Right? I would want to plug them back up in to see if I get extraneous solutions, but extraneous solutions typically would be made by, like negative 3 couldn't be a solution, 0 couldn't be a solution. They're typically made by making 0 in the denominators of these fractions. I'm not going to take your time by plugging these back in. We're going to assume that these are good solutions. All right, this is a slightly simpler problem. I want to multiply both sides of the equation by the least common denominator. That's going to be, this is 2 times 3. This is 3 times x. So it's going to be, I'm going to use the 3, the x, and then I'm not going to use this 3. I need to use the 2. 6x. When I multiply 6x times this, the 3x will cancel and be 2 times 2, which is 4. When I multiply it times 1/6, 1/6 times 6x is just x. And when I multiply it times 4 over 3x, the 3x cancels into 6x and leaves 2 again, so it'll be 8. When I subtract 4, x is equal to 4. All right, so much simpler. But the key is multiplying both sides of the equation by the least common denominator. Okay, go ahead and practice that. Do problems 14, 20, and 23. Come on back and we'll finish out the lecture. Okay, so I could do a number of different things to solve this. I could make an input-output table. I could graph it. And typically, rather than making an input-output table with 8 points, I probably would look at graphing this. So I'm going to go ahead and I'm going to bring up a piece of graphing software. And I'm going to go ahead and put in my equation. So what's complicated about this is making sure that I put it in correctly. So I'm going to want to put this in parentheses divided by this in parentheses. Y is equal to, open parentheses, that's going to be very important. So I'm going to have 848x. I've substituted the t for x squared plus 3220. And this value needs to be divided by 115 x squared plus 1000. And here's my graph. Now, this is a graph of a rational function, right? You'll notice that this is going to be interesting. You notice it has the same degree, so the horizontal asymptote would be the ratio of 848 to 115, so 3.22. What we're looking for now is we're looking for where, let's go back to our question, where is our total sales 5.3 billion? So we want to look at, let's see, here's 5.3. Looks like it's right around, there it is, in 3 years, 5.33. So I could have made an input-output table, and I would have eventually found this, but what's nice is if you're going to look for a specific value from an equation like this, if you graph it, it's pretty easy to find that point without doing a lot of mess. Okay, so in year 3 would be the time that would happen, so that would be in 1998. Okay, so you have a lot of different tools at your disposal. I could have made an input-output table, would have taken a fair bit of time. By putting this into a graph and using a graphing calculator, it gets me to the answer very, very quickly. And also, if I wanted a wide variety of answers, that would also get me the answers very quickly. I could also go back and use that to create the graph to create the input-output table. So you can use the input-output table to create the graph, or you can use the graph to create the input-output table, whichever works best for you.